The lesson for today is the oscilloscope. As you can see, this is the oscilloscope. I did preview before. It's like an x-ray machine for doctors that shows the doctors how the patient look inside. But this one won't show us exactly the wires inside the components, but rather it will show us the signal. You need only 5 volts to power this oscilloscope. This jack goes to the back of the oscilloscope, and this USB type A, you connect it to the 5 volt socket. It can either be a cell phone charger or the power bank or any 5 volt source. This button at the bottom, we use it to switch on our oscilloscope. Now it is on. So today I will teach you, I will take you through all this button and the screen on how to read the signal. First we'll start with channel 1. This is the signal for channel 1, the yellow one. It is written 1 there, so it is for channel 1. If you want it to appear, you press this channel 1, or if you want it to disappear, you press this channel 1 button. If you want it to appear, you press the channel 1 button again. This yellow one written config is for configuration. You decide the signal on the oscilloscope. What must it show you? Must it show you the exact signal that you get from the circuit, or it must be divided by 10. If you select 1x, it means it is exactly as it is from the circuit. If you select 10x, it will be divided by 10. So whatever value you get on the oscilloscope after calculation or analysis, you multiply it by 10. If it's 100, the same applies. You can also select the coupling, whether the DC or AC. I selected the DC. In future, as you grow along in this field, you will know the exact difference between the AC and the DC coupling. The DC coupling will show you the signal like it is. It also shows you the DC offset. The AC coupling, it shows you the ripple wave in case of a power supply, whereas on a DC coupling it won't show you those kind of things. And then you can also display the FFT on screen or not. I prefer it off. And then this knob you use to select the voltage per division, meaning you select what each box here, how much voltage must it represent. If you select 1 like it is here, this is channel 1, and then the voltage per division is 1, which means now if I were to connect the oscilloscope probe on a circuit and then it jump once above this box, it means that output is 1 volt. If it jump above 2 boxes, it's 2 volt, meaning it is 2 multiplied by the voltage per division. If now I set it, let's say, to 2.5, if now the voltage jump above 1 block, it will be 2.5 volt. It's 1 multiplied by 2.5. If it jump above 2, it will be 2 multiplied by 2.5, which will give us 5 volt. Now let me set it to 5 volt. Let me measure the voltage for this battery. The hook goes to the positive of the battery and the crocodile clip goes to the negative. You see it jumped to almost 2 boxes above the 0 line. So I assume it's 1.9. So it will be 1 full box, and then it's right there by the dots where it's almost 2 blocks, but actually it's not exactly 2 blocks. So it's more or less 1.9. So you say 1.9 multiplied by 5, then you get approximately 9.55 volt. Here the oscilloscope indicated the output voltage for this battery, which is 9.55 volt. That's how you read the oscilloscope. Now let's go to channel 2. Let's switch off channel 1. Channel 1 is off. Now we see channel 2. The knobs are exactly the same for channel 1 and 2. It's just that if you adjust this side, you only make changes on a channel 1 signal. If you adjust on channel 2 position, you only adjust channel 2 signal. But the channel 2 buttons operate the same way, or exactly the same way as channel 1. The same with the config. Meaning if we did configure channel 1 that was only affect the signal of channel 1 of the oscilloscope. Now if you configure channel 2, that was going to only affect channel 2. And then this voltage per division work the same as that one of channel 1. So it basically is exactly the same thing. Then this side, that's where we move the position of a signal horizontally. Here we are moving the position of the signal vertically. Here we'll move it horizontally. Now to be able to see the exact position of the signal moving horizontally, we'll have to generate a square wave or any type of a wave and see it move horizontally. This oscilloscope is the best because it has an internal generator. So we can generate the signal here using the generate button and then feed it to one of the probes. So I'll feed it to channel 2. Let us generate the signal and see. Now here you can select whatever signal that you want to generate. I want a square wave, but we'll just go through and see all the type of signals. You see the triangular, the sawtooth, another sawtooth. There are many. Half wave, full wave. You can generate each wave that you want. Sine wave and back. Here we have a frequency for the wave you want to generate. I will choose 100 Hz. I want a square wave with a duty cycle of 50%. You can change or you can tune through this selection using the OK button, or you can move the duty. You can change the duty cycle using this knob, and then you move. If you want to change the frequency, use these arrows. I want to use 100 Hz. Then it's okay. Then the square wave. If you want to change the wave, you use the arrows, but I want the square wave at 100 Hz with a duty cycle of 50%. Then I'm happy with it. Then I can connect my oscilloscope probe of channel 2. The red probe from the generator goes to the hook, and the negative, which is the black one, goes to the crocodile clip. Now it's set and we're good to go. Now I'm positioning my wave horizontally up, no, vertically up. If I want to make it big, I can change the volt per division. Now you see how we use the volt per division. Now it is 5 volt per division, and the position of the waveform is at 3 volt. If I want to move it, it's at 1.2 volt actually. Now if I want to move it horizontally, I will use this knob here. Then I can move it horizontally. If I want to change time, right now the time is 10 milliseconds per division. Now the time and the voltage is different. We said the voltage one, it goes vertically up like so, but now for time it goes horizontally. We count blocks in a horizontal direction. 1, 2, 3, 4, 5, 6, 7. There are 7 in actually there are 14 in total, counting the 7 on the other side. If I want to change time, then I can change it like this. You see it changes here from 10 milliseconds to 5 milliseconds, 2 milliseconds. And then if I want to know the exact time it takes to complete a cycle, I can just put it where I can start counting. This is the right position, and then the time it takes to complete one cycle is from here to this position. So I can count 1, 2, 3, 4, 5. There are 5, and then I'll say 5 multiplied by 2 milliseconds. Then it will give me 10 milliseconds. That means the time it takes to complete one cycle is 10 milliseconds. Then moving over here, the triggering. Now the triggering part it will be a little complex for you. So you adjust the trigger here. When the signal rises, especially the sine wave, when the signal rises, let's check the sine wave. Now this is the sine wave. That's how a sine wave look like. Yeah. Now that's how the sine wave look like. More especially the sine wave. You might want to know where exactly the oscilloscope start triggering the sine wave. That's where you make the adjustments. Where the oscilloscope will start triggering, you change the level of triggering here. You also change whether you want it to trigger on a fall or on a rising edge. Then here we change the mode. Here where the mode is changing, it changes from auto, which means now it triggers automatically. It triggers only the single wave at a time. Here it's normal, but I prefer automatic. And then you choose the edge, whether it must trigger on the rising edge or it must trigger on the falling edge. You see, as I change the mode of the edge, even the signal changes. See? But I also prefer the rising edge triggering. And then the channel, you choose here whether you want the controls to affect channel 1 or channel 2. Since we are working on channel 2, I will leave it on channel 2. Then we move over to auto. The auto button, if you try to make adjustments, especially if your wave cannot settle, let's say your wave is like this and you seem like you can't set it, you just push the auto button. Then the oscilloscope will know exactly when to trigger and how to display your wave. Now if you want to take measurements, let's go back again to the first moving. If let's say you are happy with it like this, but you want to take measurements and you cannot take measurements, you can push the stop button. That's when now you can take your measurements, make verification and analysis. If you are happy with your analysis and everything, then you can run your signal again. Like I said, if you don't know what to do now, the signal is like this, then you press auto. Then the oscilloscope will know exactly when to trigger and to display what type of a wave, and not exactly the type of a wave, but how to display the wave on the oscilloscope. This button that you see here are for the picture. If you need to take a picture of this waveform, you go to menu and then go down and then you capture this output picture. You press OK, then it's captured and saved. If you want to see the pictures that you've captured, you go to menu, picture, and then you go OK on picture browsing. Then you see the pictures you captured. These are the old ones. Actually, I must press next. Then you go to menu again. Then you check your wave browsing. No, it's the same as it. These are the output waveforms. If you want to send them to the external drive, like a memory stick, you select them all. Then you go to menu. Then you export them to the USB. Then you go to menu to exit the sending of the pictures. Now let's say you want to know the exact time for each waveform here. You will then go to H, and then it's already selected, but now let's say it was like it was like this. You want to come here, you just press this arrow, it will come here and select, and then you move it. If it was here, then you press this arrow, then you select this one, then you move until maybe you get to this point or wherever you want. I want to measure it from here. If it's too fast, you press slow, then just move slowly so that you can be precise. Now from here to here, it takes 10 milliseconds or 100 hertz. Now if I want to know the voltage from peak to peak, I press the V curve. Then I can place this one at the top, place this one at the bottom. And then the peak to peak voltage for this waveform is 2.68 volt. It's easy, né? Now that's how you see the timing of each wave and the voltage at that specific point. But you can also come here to F1 where it will show us the waveform, but now this time around it will show us in a digital format. If you press F1, it will select the volt peak to peak for channel 1, but on the other hand it can still display everything. You see the voltage that you saw, that you just measured now, the 2.68 volt. It appears there, the voltage peak to peak. The time that you just saw, the cycle is 10 milliseconds. The frequency is 100 hertz. You can still see everything here. F2, it shows the average, but it can still show all the information that you just saw. So you can either press F1, F2 up to F6. You will see all the information that you want to see. Now coming back to the screen. On the screen, this is the voltage peak to peak for channel 1. At this moment in time, channel 1 is not connected, so the voltage peak to peak is 0. The voltage average is 0. The frequency is 0. But for channel 2 is connected to the internal generator. So we see the peak to peak voltage is 2.68 volt. And the average voltage is 20 millivolt. The frequency is 100 hertz. Whatever it is marked with yellow represent the readings for channel 1, and the one that's marked with blue represent the reading for channel 2. Even here you see this is channel 2 with the blue. The voltage per block is 1 volt, or the voltage per division is 1 volt. The position of this wave is at minus 20 millivolt. We can adjust it to 0. Now it's at 0 volt. You adjust the voltage position by using this position knob here. Now it's back at 0. If you want to move it horizontally, remember this is the knob. Now coming back to the probes. The indication for channel 1 probe is red, so make sure that you put the red ring, and here as well on the probe itself, so that when you connect it on a circuit output, you will know exactly which probe represents which channel. You won't be confused with the readings. Here on a probe, if you want to minimize, let me use the one that is connected to a signal generator. On a probe, if you want to increase or minimize the size of the signal, you can also use the slide switch here on the probe itself. Meaning if you select times 10, the input signal from the generator will be divided by 10. So whatever value that you read on the screen, you must multiply it by 10. But if it's like this, it means whatever signal that you get from a probe is exactly what is displayed on the oscilloscope, since it is multiplied by 1. Here, that's where we select our photos. That's where we use next when we're viewing the previous one or the last to go back to the previous picture. If you want to delete them, you delete them. If you want to select all, select all. If you want to select one, the one you're viewing at that moment, use this select. Basically, that's how the oscilloscope operates. I hope you'll enjoy the course. Next time we meet, we'll be talking about inductors. That's where we'll be using an AC generator. That's why I had to teach you the oscilloscope first, so that when we power our circuit with an AC signal and then we test using oscilloscope, you won't get confused. The class is adjourned. Until next time.